We're now going to look at equal vectors. To demonstrate this, we're going to look at the four vectors A, B, C and D that are drawn in the grid below. What we're going to do is work out the I and j components for each of these vectors. So let's start with vector A. So to get the I and j components, we're going to start by traveling from the tail of vector A to its nose. So we're going to move horizontally first, and then we're going to move vertically. So we're moving 4 squares to the right, so the I component is going to be positive 4. So we're going to write 4I. And we're moving up, so the j component is going to be positive, so it's going to be 2j. Let's do the same for vector B. So for vector B, we're going to start at its tail and travel to its nose. So we're going to have to move horizontally first, and then we're going to have to move vertically. So the horizontal distance that we move, well, we're moving 3 squares to the right. So that means the horizontal component, or the I component, is positive. So it's 3I. Positive 3I. We're then moving 4 squares down. So the j component is going to be negative 4. So we're going to write negative 4j. Okay, vector C, we're going to travel from its tail to its nose, so we're going to have to move across to the right, and then we're going to have to move down. So we're moving 3 units, or 3 squares to the right, so the I component is positive, so it's going to be 3I. And then we're moving 4 squares down, so the j component is going to be negative, so that's going to be negative 4j. Okay, the last one, vector D, if we start at its tail and travel to its nose, we're moving horizontally to the right, and then we move vertically upwards. So, because we're moving to the right, the I component is going to be positive, so it's going to be positive 4, and we're going to write 4I. And then we're moving upwards, so the j component is positive, and it's going to be plus 2, so 2j. So, let's write each vector A, B, C and D as a sum of its I and j components. So vector A is 4I plus 2j. Vector B is 3I and then minus 4j. Vector C is 3I minus 4j. And then vector D is 4I plus 2j. Now, you can clearly see that the I component of A is the same as the I component of vector D. The j component of A is the same as the j component of D. So therefore, vectors A and D are equal. They have the same I component, and they have the same j component. And likewise, if you look at vectors B and C, you'll notice they've got the same I component, and they've also got the same j component. So B and C are equal. However, equal just doesn't mean that the I components are the same and the j components are the same, because if you look at the vectors that we've drawn, so we said that A and D are equal. There's A, there's D. Yes, they've the same I component, they've the same j component, but not only that, they are the same length, they are parallel, and their arrow direction is the same. So those are the 5 properties that equal vectors have. They are parallel, they are the same length, they have the same I component, the same j component, and they have the same arrow direction. Okay, let's finish off equal vectors with a straightforward little example. So it says, find the values of A and B such that the vector on the left hand side of the equal sign is exactly the same as the vector on the right hand side of the equal sign. So these two vectors are equal. So that means that the I components on each side are the same, and it also means the j components on each side are the same. So we're going to equate the I components. So equate I. So we're going to get 2a plus 1 and that's equal to the I component on the other side, 4 minus b. Okay, I'm going to bring a and b to the same side and the numbers to the other, so we'll bring minus b over, so we're going to have 2a plus b, and then bring your plus 1 over, we're going to have 3. And we'll call that equation 1. So you can see so far we've an equation with 2 unknowns. We're going to have to set up another equation with 2 unknowns. So we also equate the j components. So the j component on the left hand side, which is b minus 3, is equal to the j component on the right hand side, a minus 6. So again, I'm going to bring the letters to one side and the numbers to the other. So we'll bring b over, so we're going to get a minus b on one side. And then bring your minus 6 over, minus 3 plus 6 is going to give us 3. And we'll call that equation 2. So you can see that we've got two simultaneous equations. So simultaneous equations. So we've got 2a plus b equals 3, that's equation 1. And we've got a subtract b is equal to 3, and that is equation number 2. So the easiest thing to do here is to add the two equations to eliminate b. So if we work out 1 plus 2, so 2a plus a will give us 3a. Minus b plus minus b is just going to wipe b out, and that's just going to give us 6. So divide by 3, we're going to get a is equal to 2. Call that equation 3, and then finally we're just going to sub a into any of equations 1 or 2. So sub a equals 2 into 1 or 2. So probably easiest one, chuck it into 2. So we're going to get 2 minus b is equal to 3. So bring your 3 over, we're going to get negative 1. Bring your minus b over, we're going to get b. And that's equation 4. So our final answer then A equals 2 and B equals -1.